Good morning. Today I have the pleasant duty of welcoming and introducing the guest speaker for the day, Mr. Shanmugam. As I informed in the previous class, today we are going to have a guest lecture on reverse engineering. And that too from an industrial practitioner who is an expert in doing reverse engineering. So we thought it will be very appropriate for our course to have this lecture today. I'm sorry for the delay, we had some hiccups, so we could start it only after a small delay. I apologize for that. Now I welcome Mr. Shanmugam for the lecture today, and let me briefly introduce Mr. Shanmugam. Mr. Shanmugam is presently the Director of Design Desk India Private Limited. Design Desk India Private Limited is a company which is involved in extensively product design. He graduated from IRTT and he did his post-graduation from MIT Anna University. He also has a brief career in teaching, after which he started his own industry. The primary focus is on design services. His areas of expertise include automotive components, and right now the design desk company is also diversifying into wind turbines, which belongs to the energy sector, which is one of the emerging sectors in the international scenario. He is an active SAE member and he is also a PDMA member. He is a managing committee. He was the managing committee member of SAE Southern Section. For the year 2003 to 2009, he was the treasurer of SAE. He has taken, as an office bearer of SAE, he has taken a lot of initiatives in activating or revitalizing the SAE activities, particularly the student activities of SAE. He is one of the architects of a World in Motion program organized for school children by SAE. This is basically a program which is supposed to, which is introducing a spirit of scientific inquiry among school children. It is a huge success, and hundreds of schools in and around Chennai and all over Tamil Nadu are participating in this program. He is a lead faculty for SAE Truck program, again a student-centric SAE activity program. He had organized various conferences. He has delivered guest lectures very widely. He has published papers in international conferences and journals. He has visited many foreign countries like US, UK, Germany, China, Malaysia. He is an expert in product design and reverse engineering. He has conducted many workshops in reverse engineering. He had conducted reverse engineering workshop for industrial personnel. In fact, recently he had conducted a workshop on reverse engineering for WAPCO China. WAPCO has established a facility, a design facility at China. He recently conducted a workshop on reverse engineering for WAPCO China. He is closely associated with our university. He had visited us many times as an advisor for SAE activities. And I have a great pleasure in introducing and welcoming Mr. Shanmugam to deliver a lecture today on reverse engineering. Now I request Dr. Rajendran to say a few words about the SAE.
Good morning, everyone. I'm happy to organize the guest lecture on reverse engineering on behalf of Society of Automotive Engineers. So it's basically an society which is basically we are doing the activities for the students, professional engineers and school children. So this SAE, it's nearly 106 years old society. It has the headquarters in US. So nearly we have 110 countries being member in SAE. So in India we have nearly 5 sections: northern section, southern section, western, eastern and Bangalore section. So we are the SAE India is the largest affiliate to SAE International. So basically in southern section we have nearly more than 100 clubs, collegiate clubs organizing the student activities. So in India we are in the southern section is the largest affiliate. There is basically having more members and more student activities. So talking about the student activities, we have the Tier 1 events as a part of student convention. So we have a student convention which is being organized every year, wherein we have 8 different competitions which is conducted in 3 different levels. So Tier 1 it will be at the college level, then Tier 2 it will be at the division level, then Tier 3 is the convention, it's the finals. So Tier 1 at the college level we have nearly 8 competitions, basically to test the skills in design, fabrication. So the main idea is to convert the theory into practice. So whatever the theoretical knowledge you gain through the subjects you study, that has to be put into practice. That is the main objective we focus in the SAE. So for this we try to organize the events like aero modeling, then you have the paper presentation wherein you get the deep dive knowledge, then you have the quiz, so you get the literature survey and the knowledge from the books and the internet. Then you have the using the softwares, so we have modeling and animation, then we have the computer manufacturing, then we have the analysis. So this is basically important in an industry, what you are trying to do. So whatever the product you are trying to design, that has to be analyzed and it has to be manufactured. So we need to analyze what is the problem between the theory and practice. So if we talking about in theory, you will be designing a fluid flow in a pipe. So what will happen when a fluid flows? So when you want to change the velocity or increase the speed or anything, so you try to have a larger diameter or smaller diameter. But when it comes to practical thing, we find it difficult to manufacture either a larger diameter or very small diameter. So there is a constraint. So we need to look into what is the problems we face in converting the theory into practice. So this is the need why we organize this event or the competition, so that the students will be exposed to the theory as well as the practice. So we'll be shortly organizing the aero modeling workshop for the first years on February 25th on Saturday. Then we are also planning some series of workshops on automotive and then Bhavana and other things in the coming March. So we'll be participating in the various competitions, the aero modeling and other competitions also. So apart from this, we will be having the what you call the Bhaga. So basically, the Bhaga dealing with the all-terrain vehicle. So we need to design and fabricate a vehicle. So that will be the what you call the application call for will be coming shortly in March. So that we will need to file the application. So basically, the main idea of this event is to give a focus on the practical exposure. What you're trying to learn, that has to be put into practice. So we had a very good placements during the Bhaga and Formula SAE that has been brought recently in 2011. So that is known as the Supra SAE. Then apart from that, we have a program called SAE Tracks. Basically, we try to teach the engineering design process in alignment with the nature. So it's a 2-day program, where in day 1 it will be focusing on the how you are making the students ready to get the design. So what is design? So it's not just using the Pro and doing it. It's just a tool. So wherein you teach what is the basics in design. Second day you'll be going for a trek to a particular spot or anything. Then apart from that, we have programs like ASOP, wherein you are trying to make the students industry ready. So one of the things is in ASOP, it's an automotive student orientation program, wherein we try to focus on the reverse engineering. So it's basically we teach the design, and then they try to fabricate a vehicle, and then they try to build a prototype and test run it. And then they have in the final year they are given an industrial project. So they get a complete what is an industry, what is design, how to get it to the. So we are just preparing the students for the industry. So this is the objective in the ASOP. So I think you can just go log on to the website www.saeiss.org for various activities we conduct. So we also do the factory visits and treks. So you can just register for the programs. you can log on to the website www.saeiss.org. saeindia7section.org.
My apologies for the delay. Okay, I'm the reason for the delay. You have to excuse me. But then we will take about roughly about 1 hour, and the presentation or lecture will be for about 30 minutes, 20 to 30 minutes. We will have a long interactive session for 30 minutes. Okay, you have questions or any clarification required, we will discuss in detail. Okay, basically, I would prefer this, going like a kind of an interactive session rather than a PowerPoint presentation, something like that. But then, because like you are in a second semester, I'm not sure how much, the benefit we can derive by, straight away going for a discussion. Good. Okay. Okay, so what is the reason you are here? Huh? Very disturbing, right? The question itself is not correct. How can you come to an engineering college asking why am I here? Why are you here? What? Attendance. This I like. Attendance. Okay. So what else? And this is not going to be a regular lecture. You will enjoy. Okay. I'll make sure that you enjoy. Right? So maybe I do understand. Okay, how the class or lecture can be interesting, but that's my problem, not yours. Okay. So what is engineering? What is engineering? See, you are all opted for mechanical engineering or what else? Huh? Aeronautical engineering. Good. So in every major this thing, you have engineering there. So what is this engineering? What is engineering? Huh? No, I'm not getting. I'm not hearing. Design and manufacturing. I think you have a problem again. Okay. Now you are introduced to two keywords: design and manufacturing. So what is design? What is manufacturing? Huh? See, if you guys talk, everybody talk at the same time, so I can't hear. And even if you talk, at least talk louder in this class. Okay. So what is design? What is manufacturing? Pardon? Okay, now he is introducing one more keyword, concept. Okay, so you see, we started with engineering. So he says engineering is design and manufacturing. Then I asked what is design? He says concept. So, I need to type. Okay, so he has introduced one new keyword, we call keyword. Because like when I did engineering 25 years back, okay, that is 1988, I finished my BE automobile engineering. That point in time, okay, even after I finished engineering, I didn't know what is engineering. Okay, I got a degree. He says, no, I am a first class with a distinction, blah, blah. But then I have no idea what is engineering. So, they say, okay, when you get a driving license, that is when you start learning driving. That is when you start learning driving. You got a license, you can take a car or a bike, then you can drive on the road, am I right? Exactly, that's what happened to me. When I finished engineering, I didn't know what engineering is. Okay? Then last 25 years, 22 years. Yeah? So I really know, the hard way I was trying to understand what engineering is. Okay, my definition of engineering is making things work reliably. Making things work reliably. So if you say reliably, again another keyword. So we started with many pens, color pens. Okay, we have engineering. One of you said it is design and manufacturing. Yeah, in design also somebody said concept. Actually, design is a different word. Okay, design is a different word. It is not even connected with engineering. Manufacturing is altogether a different word. Please understand, when we say engineering, okay, make things work reliably. When I am switching on the light, I want to see the room illuminated. If it's not happening, I know there is a problem with the bulb, or the circuit is not closed, or there is no power. So, if I say it's not working reliably means, so the bulb is okay, there is power supply, still I switch on, but there is no illumination in the room, so obviously I understand the circuit is not closed. That means switch is not doing its function. That is a failure. Now you look at actually how many keywords has come. Okay, so we started with engineering, make things work reliably, make things work. Okay, sorry, you should forgive me. Okay, make things work. Things work reliably. Okay, I had an opportunity to discuss is exactly precisely that actually. You should build a vehicle, you should engineer a vehicle. We call it Mercedes is a well-engineered car. Mercedes is a well-engineered car. Yeah? So, make things work reliably. That is engineering. So, design, okay, what is design? When you say design, immediately what you should think? You should think of a customer. Because there is no customer, no design. So, a customer has a need and expectation. A customer has a need and an expectation. So, what's a need, what's an expectation? What do you do when you are hungry? You go to the canteen. Correct? Yes, that is a need. Okay, morning 9 a.m. you finish your breakfast in the home, but still you want to go to the canteen. Why? There is a need. You want to chit chat with your friend. Yeah? Correct. So then what is expectation? Expectation is when you get into a restaurant, you expect it to be clean. Yeah? The menu you want must be there. When you order it, it should come in about 5 minutes. You want a good service. These are all expectations. So as a customer, many a time, yeah, I used to tell, customers, they have no idea what they really want. They have no idea what they really want. Why? Very simple. You are going to your restaurant. Yeah? Just run your mind through the process. When you are entering into the restaurant, what do? You find a place, sit, somebody comes, he is giving you a menu card, you go run through the menu card, then you ask him, yeah, what is good in this restaurant? What is good in this restaurant? He says something, X, Y, Z, something like that. Then you are asking him, which one I will get very fast? He says some item, huh? Water, okay. But for water do you pay? No. So, what you are asking is, how fast an item can be delivered. Then what you ask? Will it be hot? Okay, suddenly 3 tables down the row, just you look at it. Somebody is eating something red or radish in color. Okay, You're thinking, what is that? No sir, that is a special dish. Fine, you bring me one plate. Bring me one plate. So the trouble is, as a customer, I may be there for 30 minutes. As a customer, I may spend about 100 bucks or 20 bucks. But as a customer, even to choose a menu for a lunch or breakfast is so difficult. Or I say, like that may not be very polite, but then I say, customer. Because he cannot tell what he really wants. Because many a time I look at people, okay, somebody is telling me, sir, I am going to buy a bike. Hey, great, huh? Then what do you do? No, my uncle is having that bike, so I am going to buy this bike. And I am switched off. Okay? I am asking, why you are buying a bike your uncle bought? Sir, that is a good bike, it's giving good mileage. Yeah. Which bike you are talking about? He says a particular bike. Hey, do you know in that bike, the bolts and nuts are not in the same way in any other bike. That means you cannot get a spare for that bike from any other service dealer. You have to go to that manufacturer service center. They have designed in such a very nice way. Okay? You want to buy a bolt, you can only buy from them. So, when we say design means a customer. Without customer, there is no design. A customer has a need and expectation. Customers negotiate on the expectation. They never negotiate on the need. Yeah? So, you go to a place where you got some 5-6 restaurants, so you always know where to go because you know which is a good restaurant, which is cheap, which has the menu you are interested in. Yeah, where there is a fast service. So obviously you go there. So that's a choice you are making. But mind it, you are in a desert. Okay? Last, say 1 week, you didn't have the food. So somewhere about 100 feet from where you are standing, you see a small hut where food is being served. At least that's what you are looking at. Okay, you just get into the hut, you look at the person, he's very ugly. In the sense that he's smelling. He's smelling. I don't know when this fellow has taken a wash. Okay? I could see some, like dirty things on his nails also. The food is of not good quality. But my question is, will you take the food or you just walk away because these things are not good? Yeah, what do you do? Blue. Don't look at him, You have to make a choice. He's not there, Yeah, you are the customer. You take the food, great. No, he's great. Actually, no, this is the correct answer. Here is a question of survival. The need is, I need to survive. Okay? I don't know how many of you are watching Man and Wife in Discovery Channel. He takes so many food. But do you know why he's taking such things? Very funny dishes. Free of cost. My God. For every episode, he's getting paid 1 crore, $250,000. For every episode. Yeah? Obviously, money is the need there. So, customers negotiate on the expectation. That is, he's smelling, the food is not good, maybe this is 1 week old, you can tell 101 things. But he still takes the food because survival. Whereas need, you don't compromise. You don't compromise on the need. So now, what's happening is, when a need and expectation is documented, you're documenting it. It becomes a requirement. Okay? So there is a customer requirement. What is a customer requirement? He wants this car to go maximum speed 120 kilometers. Yeah? 0 to 60 kilometers in about 6 seconds. Many a time when I see such advertisement, I feel this is a very stupid advertisement. Why? Very simple. Do Indian roads can support 0 to 60 km in 6 seconds speed? No way. Even a tested track, a very standard tested track, you cannot achieve that speed. So I am puzzled. Who will be buying this bike? Okay, fine, he is buying a bike. Then where he will ride the bike? Obviously on the roads only. God save those fellows who are walking on the road, because somebody is going to drive a bike with a 0 to 60 km in about 6 seconds acceleration. Because this is the problem. This is the reason I am here. This is the reason now we are discussing. Why? Because if somebody is designing a bike for Japan, somebody is designing a bike for Germany, I can understand those roads can support that. But if somebody is designing a bike for Indian conditions, obviously the guy who designed that bike, either the bike is not designed for India, or the guy who is selling the bike in India has not developed a bike for Indian conditions. Because our conditions are different. Our requirements are different. As customers, our requirements are different. In a country where we are very sensitive about price. So obviously fuel economy is one of the most important criteria. You look at actually, I can map the bike, I can map costs. Which one gives a good mileage, which one doesn't give a good mileage. So obviously the car which is now giving the highest mileage, that must be the choice, right? That must be the largest selling car, right? Yeah? That must be the largest selling bike also. Actually that is what I also thought. Actually it is not. That is where many a time an experienced engineers, even experienced engineers get confused. Because actually what customers want, really want, he says no, he is very much interested in fuel economy, he says he is very much interested in power, he says he is very much interested in pickup, he says I want a good brake, but then he wants a bike at 10,000 rupees. Yeah, something somewhere seriously wrong. Yeah, so this is where you have when you say need and expectation, is a requirement. So we have customer requirement, we have market requirement. What is my competitor doing? Yeah, then there is a government has put a regulation law. What should be the specifications in your bike? What kind of safety features are okay? So this we call it as regulatory requirements. Yeah, and there is an environmental requirement. Okay, this should be the pollution level, this should be the NOx, this should be the suit allowed. So I have customer requirements, market requirements, government legal or regulatory requirement, or my environmental requirements. All put together, all this becomes my PDS, product design specification. Product design specification. Okay, so why are we talking so much on customer requirements, needs, expectations? Why are we doing all these things? Very simple. Because somebody said very casually, without understanding the meaning of design. At least now you know what is design, right? So if you talk about design, you need a customer. When there is a customer, he has a need and expectation. A documented need and expectation becomes a requirement. You have different types of requirements: customer requirements, market requirements, legal, regulatory or government requirements, and environmental requirements. All put together becomes a product design specification. So this is design. So ultimately, you build a vehicle that should meet these requirements. If it is not meeting that requirement, then obviously there is something seriously wrong with the design. Something seriously wrong with the design. So this is design. So what is manufacturing? Okay, once you finish the design, you release the drawing for manufacturing, or we call it as build. Okay, you can build a part, you can build an assembly. When you build a part, it goes through a process. Okay, you have a geometry, you have a material, you have a manufacturing process. Okay, so each one is by itself a domain. Each one itself is a domain. That's why we have manufacturing engineering or production engineering. We have like design, engineering design. You go to MTech level, you have engineering design or product design. So there are many vastly different areas. So let us not get into that. So when you say design, So design is basically comes with a product design specification. For that, what you do? That is design. But manufacturing starts with the product, like drawings or part drawings. Okay. Now let us go to the concept. What is concept? Okay. Now we have to go back to our 6th class physics. Why 6th class physics? Because that is something we don't like, right? It has not been taught in a way, in an enjoyable way. In an enjoyable way. So let us look at the concept. Because concept has a direct correlation with what we will be discussing in reverse engineering. Okay. Now let us look at concept. What is this thing? There are two types of physics. Since you are a mechanical engineer or aeronautical engineer, yeah. One physics we call it as design physics. Other one is manufacturing physics. Manufacturing physics. So let us look at when we say physics, don't think about very complicated equations. I'll make your life very simple. Okay? Hey, how many of you are sleeping here? Huh? When I say okay, there is not even one single voice. Okay. I'm not hearing. Correct. Okay, now you are all now wake up. Okay, let us look at design physics first. Okay? Okay, thank you. Okay, let us look at the design physics actually. Okay, again I am introducing some 3 keywords. Okay, at the end of the session, we will be identifying the keywords which we discussed so that you will remember. Because the best way to learn engineering is you have a syllabus, yeah, and identify the keywords, and you must know the definition of the keywords. Once you know the definition of the keywords, 90% you can write in the exam. Okay, so now let us look at the design physics. Okay, look at this. Actually, this is, I call it as function. This is function. So this is my geometry. This is my geometry. This is my material. Okay, let us look at this now in detail. So what is a function? This is a cap for this pen. So what is the function of this cap? Okay, so he is telling to protect the tip. Okay? Protect the tip. Fine. Actually, many of you know, even people who are in the business for the last 30 years, 35 years, because I work with the different people, yeah, there is one important thing which is not taught in engineering, whether it is undergraduate, postgraduate, even at PhD level, is the function. Because many a time there is a word in English called function, and we know, go to the dictionary, we come to know what is a function. Fine, but that's not function. In engineering, function is a serious business. Okay? When you buy a product, you are not buying a product, you are buying a function. What is the function you are buying? Okay, you are buying a washing machine. So what is the function of a washing machine? Wash your clothes. Wash your clothes. Okay, why are you buying a motorcycle? Huh? No. Please understand, if you all talk, I cannot understand. Okay, to make transport easy. Okay, again I have a trouble. Okay, what is the trouble? To transport it? To make transport easy. Okay, fine. Now, you should know the difference between transport and commuting. You can only transport the goods. What is a good? Luggage. You can only transport the luggage. If it is for human being, it is not called a transport. It is called commuting. It is called commuting. So, very good, because I cannot tell now, because video is being lectured, maybe it may go. So I cannot put the name. But then I can share that interesting story. Very early on, at least 15 years back, I met one company's product development director. He's an Irish man. And he was telling me, this thing, Sharma, look at this. In India only, yeah, you build one chassis. Yeah, the same chassis is used for transporting the goods as well as for commuter, this thing. That's a bus. The same chassis. The same chassis is used to transport the goods as well as for moving the people. Do you understand anything? What do you understand? I didn't understand this that time, but I'm really surprised when you say yes, you understood. What is it that you understood? Louder.
Truck and bus,
Truck and bus, they use the same chassis. Is it okay? No, I'm asking that person. Is it okay? Is it okay? It's okay. Very bad customer, huh? Very bad customer. Have you traveled in any Volvo bus? See, by any chance, I'm not telling Volvos are the best bus. Okay, so there are better buses, but then the point is, bus is supposed to give you a comfort. Yeah, if there is a vibration, it is supposed to isolate the vibration. Yeah, that is bus. Suppose you got a goods, you got a luggage, 4 ton, some machinery or something like that. What is your problem? Can that be this thing? Can that be taken in a bus? No. Is there any problem with vibration? Obviously, if there are any vibration sensitive equipment is there, then it is to be transported properly. But otherwise, okay, for goods, yeah, you need a suspension, but that stiffness has to be different between your regular transport truck and your passenger bus. You should have different suspension system. Okay, coming here, let us look at the correct way of defining a function. The correct way of defining a function, you have it is in a format, it's in the standard format. Because look at this actually. Somebody is saying transport easy, wash your clothes to protect the tip. Right? Okay. Once this class is over, if somebody is coming here, he sees this, what he can understand? He can't understand. The reason is simple. It is not in a functional language. It's not in a functional language. This is in a regular English. Regular English. This is not in a functional language. Functional language is very simple. It has a very simple format. You use a verb plus a noun. A verb plus noun. So let us make this. Okay? Let us make this first. What is here? Protect. Tip. Protect. Tip. Wash clothes. Here, this is not correct. Transport people. Transport people. This is functional language. This is functional language. So this is a function. This is a function. So if you look at any product, anything you use, you are sitting in a chair. What is the function of a chair? It's not comfort. Support what? Huh? So, come on. Because this is the problem, huh? This is a new game. This is the latest game. Function. Functional language. Huh?
To rest our body.
To rest our body. So what do you call a bed? So what do you call a bed? Huh? Hey, you are free to laugh, but quickly you have to come to the steady state equilibrium, okay? Okay, we have to save time. So what do you call a bed? So look at the challenge actually. Even the products which we use normally in day to day, yeah, if you start writing the function, we have a problem because when you write the function can be at the assembly level or at a part level because this chair is not one piece. Okay, but suppose you remove one part, I don't know whether the function of the chair will be accomplished or not. If the function of a chair, let us say somebody said support a person. Suppose you pull one leg in the chair. Will it be okay?
No.
It's not okay. The function of the chair is not served. So out of the 4 legs you have only pulled one. So what's the problem? Can't you make 3-legged chair? Can you make it? Yes. So look at actually, you have a 4-legged chair, you got a geometry. You have a 3-legged chair, you got a different geometry. Function is same. A 3-legged chair we call home in a stool, fine, is a stool. A 4-legged chair, we call a chair and function is same. It is supporting the person. But there is a secondary function. Which one is stable? 4. Look at this actually. So every part has a function. The cap has a function. The base has a function. There is a tip that has a function. But once this becomes an assembly, it also has a function. You can consider the bus as a whole, which is supposed to transport or move people, mobility basically. Or you can consider only the steering. Providing direction. You can consider the brake. Yeah? Stop the vehicle. So each part has a function, each sub-assembly has a function, assembly has a function. So the entire thing, we call it as a system. Okay? Entire thing we call it as a system. The product is a system. So when you say bus, it's a system. But without a road, bus doesn't make sense. So you have a bus, which is a system. In thermodynamics you will be studying system boundary, environment, super system. So this is basically the boundary, system boundary. The road is an environment. There will be multiple inputs and outputs. There people will be coming in the road, going out of the road. These are all possibilities. So naturally, the bus is going to operate on the road. So obviously there are certain limitations. So anytime you can look at super system, environment, system, subsystem, module, part, component. Sir, why are we discussing all these things? To make clarity on function. Because the first portion is function. Because now, when you start design, the first thing you do is define the function. What are the functions this is supposed to do? You have a car, is it only supposed to move the people? Can I listen to the music? Okay, I have a provision for audio system. Is it air conditioned? Okay, then I got an air conditioning system. But there is a base on which you bring in the variant. Okay? So, but then geometry can change. So once you define the function, so what you get is a geometry. So basically geometry has a size and shape. So now what we do is, once you define the geometry, okay, so that means let us say, we have a shaft. Okay, this is having a diameter, something like that, of 50 mm, of length, 100 mm. Now look at this actually. So this has a shape, it is circular because this is a circular shaft. Now what's happening is, this is a circular shaft, so it has a shape, it has a size, diameter 50 mm, length of about 100 mm, so that is the size. Now, if you look at this actually, what is likely to happen? Yeah, this geometry will get its physical form once you define the material or you select the material. Once you get that material, because shape is a shape, it's in the drawing. It doesn't make sense to me. It will make sense to me once I assign or select a material. I say this is mild steel, this is cast iron, this is aluminium, this is brass. Now you look at this. Function is same, geometry is same. I can change the material. I can change the material. I can change from mild steel, cast iron, aluminium, brass. So that means there are umpteen materials, close to about 6,900 different types of engineering materials are there. Ceramics, plastics. It's a wide, variety of materials. So you have a band. Now, what's happening is you have a function. Function is you are supposed to sit, support a person. That's a function. What is the geometry? 4-legged chair, 3-legged stool. You can also have a 6-legged, whatever it is. It's a geometry. You define. Now, for this geometry, you assign the material. So all put together, I call it as design physics. Design physics. Now, what is the concept? Because we are supposed to only understand a concept. Let me give one idea, only for chair. Okay? I got a 4-legged chair, leg chair, 3-legged stool. Look at this. Function is almost the same, but the secondary function is like stability. Okay, 3-leg is less, whereas 4-leg is more. 4-leg is more. Now, function is almost the same. Geometry is different. Okay, I am giving material. Maybe this is mild steel. This is mild steel, or this can be mild steel. Instead of that, you can have plastic. This also can be plastic. So, a particular set of function, geometry, and material is a concept. Function, geometry, and material is a concept. So, this is where our physics play. Why our physics play? Because when you say physics, you study mechanics. Okay? You sit on a chair. So the mechanic says, the load is going to be distributed among the 4 legs. Among the 4 legs. That means we can calculate what will be the load acting on each leg. So obviously, you can fix the diameter or the shape of the leg based on the load and the material. Load and the material. Now you look at actually, a leg is breaking. Why? Because it is not able to take the load. It is not able to take the load. So if we say the failure, we call it as physics of failure. The physics of failure can come from any one of the 6 or 7 opportunities. One is elastic deformation. You will be studying in applied mechanics. Plastic deformation, again in applied mechanics. Fitting, fracture or rupture. Creep, high temperature. In thermodynamics you will study. And you will study wear, correction. So these are all, we call it as failure mechanisms or physics of failure. The physics of failure determine what should be the geometry, what should be the material for this particular function. So each function you have one concept. For the same function you can have different concepts also. So when you do the design, the first step you do is a concept design. In concept design, this is precisely what we will be dealing. This is precisely, that means we always say design problem is a problem of generating choices. Okay, as a design engineer I should give many choices. Okay, look at the choices available for transporting people or moving people in train. You got a suburban train, you got a regular train, you got a bus, you have an MRTS, probably some other, like you got metro. So all are options. You can go by bike, car, bicycle, walk, all are basically functions which will move a person from point A to point B. From point A to point B. So these are all options. At any point in time, we will be evaluating. As a customer, you are supposed to evaluate. What are the options? Okay, I got 6 options. Among these 6 options, which one I should choose? Because that is basically evaluation. E-V-A-L-U-A-T-I-O-N. Evaluation. Okay, what do you do in evaluation? You set a criteria. Okay, if I go by car, it is costing me 1,500 rupees. If I go by train, okay, this is going to be the price. If I go by bus, this is the same. Whereas to go and catch the train, I have to take an auto or bus to the railway station. Yeah, so to the bus station again. So look at actually, you are now weighing the options or evaluating the criteria. So that is the next level. The third level of the problem is optimization. What is optimization? Okay, for this function, okay, this is a conference room. What kind of a chair here should be? Is it very similar to what you got in your classroom? Say yes or no. Okay, okay. So essentially, function, geometry and material is design physics. Good? Okay. Let us go to the manufacturing physics. In manufacturing physics, what's happening is, okay, so this is a manufacturing process. Manufacturing process. When you manufacture the process, in a particular manufacturing process, you get a grain structure. Grain structure. Okay, this leads to material properties. Material properties. Okay, these material properties gives you functional performance. Functional performance. So this is your manufacturing physics. Okay, let us look at this. What do you do in manufacturing? Okay, for every material there are a set of manufacturing process which you study in your manufacturing engineering or production engineering. So that is your manufacturing process here. Your manufacturing process gives you a particular grain structure on the surface. Gives a particular grain structure on the surface. For that particular grain structure, you got material properties. You got material properties. These material properties give certain engineering performances. These material properties give certain engineering performance. So now, here, suppose now if your functional requirement is, let us say, yeah, you have a car and where you have a gearbox, where two gears are coming in contact with each other. Okay, what is the life of a car? Sir, when I don't know myself what is my life, so why should I care about car? Because you are buying a product. So what is the lifetime of a car? Lifelong. That's nice to hear. But your product can be designed for 100 years. Obviously you have to pay a lot of money. Whereas the life of a car is 7 years or 250,000 kilometers, whichever is earlier. Whichever is earlier. That is in 1 year, you can run the car for 250,000 kilometers. That means end of the story. It means end of the story because you take the gearbox, gear tooth alone, two gears, they are meshing with each other. Without a gearbox, power is not going to be transmitted. Yeah? This is made of two different materials. Two different materials. Or same material. Same material, same hardness. Material properties, hardness. Same material, same hardness. Now, wear rate will be something. The wear of the gear tooth will be some number. Suppose, if these two gears of different material, what is likely to happen? A material which has a higher hardness, a material which has a lower hardness. The lower hardness will wear fast. The lower hardness material will wear fast. Now, if your gear is going to wear very fast, functional performance will not be achieved. What is the functional performance? Transfer force. Transfer force or torque. That's precisely what is happening in a gear. So, it cannot transfer the force or torque. Why? Because there will be some loss, there will be more loss. In a gearbox, normally a mechanical gearbox is supposed to transmit 98% efficiency. So as the gear gets worn out, your transmission efficiency will come down. How much? I don't know. Maybe probably depends on how much the vehicle has run. Okay, what is the material they have chosen? So basically, the manufacturing physics gives you certain failures, like we need to have a proper grain structure, material properties achieved based on the grain structure, and the functional requirements or performance is determined by the material property. So design is about choosing the correct functions, and then to achieve that function you need geometry. And for that geometry, there are only certain materials are suitable, because all materials cannot be manufactured in different shapes. Materials determine the geometry you can achieve. Obviously, when you choose the geometry, you are also sizing up the material. And once you have chosen the material, manufacturing process is limited, because for a material, there is a set of manufacturing process. And for that manufacturing process, the grain structure, what you are likely to get, is only, you got a list, that's all. You cannot get anything beyond that. And for these grain structure, material properties are fixed. And for these material properties, this is the performance you will get. So as a designer, what am I doing? I am choosing certain materials. When I choose the materials, if I am not going to choose this rightly, that means it's going to be a bad engineering. It's going to be a bad engineering. Choose the right material, then it works reliably all the time, anytime. If I choose wrong material, I choose wrong function, I choose wrong geometry, sorry, I'm going to have problem, failures. You get some idea? Okay, so quickly I'll run through the presentation. Okay, before we have the discussion session, because this is the background I wanted to give you, so that when I start discussing on the presentation, because I will be using keywords, jumping from here to there. So it should not be like a puzzle. Okay, so we already know what is engineering. Make things work reliably. Okay, that is engineering. Okay, when you say reverse engineering, obviously there is a forward engineering. Am I right? Yeah? If there is going to be reverse engineering, then obviously forward engineering. So the forward engineering the forward engineering is your normal design. Forward engineering is your normal design. Forward engineering. So here, what you do is you start with the customer requirement, then you go to your functional requirement, then your concept design, okay, then you go to your embodiment design, detail design, then build, then test. So this is your product development loop. Okay. So anywhere no feedback is given, so this is all. Your feedback will always be there. So this is your forward design. That means you start with the customer. Finally, you have a build. Build is an assembly. Basically, an assembly that you are testing. So this is the normal or forward engineering process. But in a reverse engineering process, you start with the part. You go back. Sir, why should I go back? As a business, any company, is supposed to bring good products to the market. So what essentially happens, I always look at the market, look at the different products. So what I do is, I just bring a car, we say stripping the car. What is stripping the car? Completely remove the parts, one by one. How many parts are likely to be there? A medium-sized car, something like Accent, will have close to 10,000 parts. Okay? This is also called a tear down. In a tear down, you take the parts apart. When you take the parts apart, what is it that first immediately strikes you on your part? You have a geometry, right? You have a geometry, Okay, let us say this is the part I am having. So this is a geometry. This is also made of materials, not one material. There is a material here, there is a material here. So that means it's not one part. It has a two part, maybe a sub-assembly. So this is a different material, this is a different material. Now what do we do? When you take the geometry out, and you identify the material, how do you identify the material? In reverse engineering, we follow a very simple, straightforward process. Yeah, what is the straightforward or simple process? Okay, what's the definition for density? Hey, many of you are sleeping, I know. No, it's not lively. Huh? Either you are hungry or this is boring. Huh? You are hungry. Okay, let the lunch wait, no problem. Don't think I am going to yield to that. Okay, I'll finish my job. Fine. So, mass by volume is your density. Is your density rho. Now, I can take this part, weight. I can take this part and weight. So, what do I get? Mass. So, where do I get my volume? I measure the geometry, model it in a CAD package. I know the volume of this part. Am I right? Am I right or wrong? No, I'm not hearing. No, I'm not hearing. Okay, so you know the volume, how to get geometry. You can vary the part, you get the mass. So mass by volume is what? Density. Now, you have your class table, 12th standard. You use the class table? Yes. In that you have a list of material density? Say yes or no. Yes, okay, if you are looking blank, all I can understand is, oh, sorry, I didn't have looked at that. I looked at the next table. Okay, so in the class table, for every material, there is a density. Okay, you are not use the class table, no problem. Okay, because we are so lazy. Yeah, go to the web, URL is MacWeb. Materials web. There is a website called MacWeb. You go to the MacWeb site, okay, there are close to about 130 material properties. 130 material properties. You can search a material, but any one of the criteria. You give the density, yeah? For this value, what are all the likely materials? Is it a plastic? Is it an iron? Is it a copper? Is it a brass? Yeah? Because the material we say, sorry, density is like a signature. It's like a signature. What is signature? It is unique. It is like your fingerprint. Okay? So, with the density, I can identify the material. I can identify the material. So, now, materials you got grades. You got different grades. Don't worry about the grades. Because with the density, you can only identify the material. You cannot identify the material grade. Okay? Because now you have the geometry. Okay, let us look at this. We are in reverse engineering. We are going from here to here. Okay? In forward engineering, we are coming from here to here. Now, in this case, we have an assembly. Strip down the assembly to parts level. For each part, you have a geometry. You can also identify the material. Okay. You already know the geometry, you already know the material. Now you should know the function. Am I right or wrong? Is it right or wrong? So you know the function. You know the function. Because function needs to be extracted from the part. Part, when I say part geometry. I don't mean to say part. When I say part, it is part geometry. From the part geometry and material, you can extract the function. When you extract the function, you can move back. You can move back. Detail design. Then you go back, embodiment design. And then you go to the concept design. Because earlier on I said design physics. Design physics comes with concept. So this is one particular concept. Function, geometry and material is one concept. There could be 10 concepts. There could be 10 concepts. So you have identified one concept. Okay, once concept is done, from that we can generate one functional requirement and overall functions for the part or product. and then you get your customer requirement. So what the customer is asking. So essentially, reverse engineering, you are going to the mind of the designer. Going to the mind of the designer to extract function, geometry, material, manufacturing process, grind structure, material properties, and then performance requirement. All these things you are going back. Okay, here is the funny thing. What is the funny thing? So I have an accent car, let us assume. Okay, this was introduced in Indian market somewhere around 99 or 2000, around that time. That means essentially a car takes about 4 years to develop, with 450 engineers working in Hyundai, another 450 engineers working at the supplier side. Okay, so 900 people working for 4 years, you see Hyundai accent. Okay, when you do reverse engineering, you have to go into the mind of every engineer, because every engineer is responsible for one part, one product, one sub-assembly. So you have to go into the mind, extract the function, geometry, material, manufacturing process, grind structure, material properties, and functional performance. Once this is extracted, what is the benefit? What is the benefit? Because if you do this, you do reverse engineering on a commercial product, you will end up in a jail. You will end up in a jail. So why somebody should dare to do that? Because the reason is simple. The reason is simple. People do. Any company, any MNC is doing reverse engineering. Okay, so you can ask me a question, sir, is it legal or illegal? Everybody is doing it, I know, because I am working with so many customers. But what they are doing is, they say, do anything under the radar. Do anything under the radar. Not noticed by many. That is a very protected area where they do this work. Not many people know even in the company. Okay, so if you are going to be caught, can you be punished? No. Reverse engineering is what you call an approved design process as per US government or US government law. Okay, I don't know about Indian law, because at least in India we don't have such a law. At least in US, it's an accepted design practice. Then you should ask me, sir, why are you telling me it is illegal? Look at a situation in a defense. US Department of Defense, they are developing a lot of military systems. When they do develop the military systems, what's happening? Look at this actually. Okay, there is a thing we call it as development supplier. There is a thing we call it as production supplier. That means when you develop a concept, you go to testing, one person is doing. Once this is done, he gives a set of prototypes to the army or navy or the air force. They test the vehicle. Once they approve, okay, the system is okay, I will buy the system. They are buying a system. Now this has to be manufactured. So they have an order for 100, let us say, tank. At that time, the whole engineering document needs to be given to the production supplier for production. No development supplier will give that documentations. Okay, so essentially, what is likely to happen is, okay, somebody is developing, so he is going through the entire process. He has a lot of knowledge, but that knowledge is not going to the manufacturing vendor or production supplier. So the production supplier has got a prototype. So he will strip down, make the drawing, identify the material, he will start manufacturing the vehicle. So now you can understand why US says, this is okay. Why US says this is okay. It is not only the case. Okay, the same company, I know a company where they developed the vehicle, but they lost all the technical information. Some people, engineers come and go. Some disaster, something like that. You lose all the technical data. What do? You stop the production. You need drawings, you need specifications. So you have to do reverse engineering. This is another kind of situation. There are another situations. Very many times, I don't know. They give a story. when that in Apollo, I don't know how many of you listening, you heard of the story. In Apollo 11 or 13, I didn't exactly remember that this thing. There was a oxygen tank explosion when the vehicle was going from the Earth to the Moon. On the way, in the middle of the journey, what do you call, there is a oxygen tank explosion. So what happened is, they didn't know how to rectify this, because either you have to throw one person out, because the oxygen level inside the system is designed for so many number of people. Either you have to throw somebody out, or you have to take less oxygen, or you have to scrap the journey, come back to Earth. Okay, all are options. Am I right? So what they would have done? What do you think they would have done? Return to the Earth. They went, they came back. All of them alive. Because this is where the function of the system, how do you manipulate? Because there are situations where you have to manipulate the system. Okay? They assume, each breath how much you are likely to take. So they have to make it slow. You have to make it slow. So they created a similar environment on the Earth. Okay? Put people on the system. Okay? They said you take breathing very slowly. So you know how much oxygen is taking, what is the capacity, so what is the duration of the flight. All these things you know. So essentially, what they have done is, they simulated a condition what is prevailing in a spacecraft, and then make sure that the process is slowed down. Why I am telling you is, the functional requirements is ultimately responsible for the performance of the system. You say, okay, this is not working all right. Okay, this is not working all right. Fine. So what do we do? Where do I find a failure? It can happen in function, it can happen in geometry, it can happen in materials, manufacturing process, or in the material properties identification. There are so many errors. Or finally, maybe the environmental loads may not be what I have already assumed. In engineering we say, when you assume, it will make an ass out of you and me. It will make an ass out of you and me. That's the meaning of assume. Whereas when we start designing, we make 100 assumptions. So as we progress in the concept design, embodiment design, detail design, build and test stages, everywhere I am only looking at what assumptions can be killed here. What is the knowledge I got so that this assumption can be eliminated, or this assumption is not assumption anymore. Okay, this is the data. So by the time I finish my test, all my assumptions should be cleared. The check box should be ticked. Okay, so now let us run down very fast. So there are the forward engineering, design of components or interactions to ensure a system function. So you know function? Yeah? You know what is the meaning of engineering. And the structure? When you say structure, it is components, sub-assemblies, modules, and when you look at this, actually these two parts. When I am assembling this, there is a click sound. There is a interference field. That's a constraint. What kind of a constraint I am creating? Okay, with reference to this axis, there is a degrees of freedom. Okay, obviously I got 6 degrees of freedom. Some I am constraining, some I am allowing it to move. So that is a constraint. And interactions. What is the interaction? Every time I open and close, it's getting, the two parts are coming in contact with each other. That's an interaction. Okay, same material. So obviously the wear rate will be something. If it is going to be different materials, wear rate is going to be different. Some point in time when the wear rate is so high, these two are not going to fit together. So interactions. Uncertainties. Many a time products are abused. Yeah, it's not intentional, but it's our ignorance. We don't know. We don't understand. Okay, the user interface is not straightforward. It's not easy to use. So that is uncertainties. So this is linked with the function. Purposeful behavior of interacting components. When these two components interact, when I say this is getting, this cap is fastened to the base, that is a purposeful behavior. Purposeful behavior of interacting components. So the forward engineering, design of components or interaction to ensure system function. Reverse engineering is model the structure to explain the Observed function. Observed function. Okay, so this is a very straight, we discussed in very detail, and just this you could do for device, system or a program. So basically, it's not at any level, because many a time, what do you see? You can do at a system level. What is the system level? When you say your suburban train, it's a system. Why? You got tracks, you got signals, you got trains, you got guards. Yeah, you have a ticketing station. Okay, there are platforms. There are so many elements at play. It's not one part, one product. So when many products interact with each other, humans as well as technical as well as social, so obviously it's a system. So next slide, sir. So basically, reverse engineering started with the US Department of Defense. Why? Because of this development supplier, production supplier business. And why are we teaching reverse engineering here? Because we are using reverse engineering as a context for learning. So that is why I highlighted it. Knowledge building, rapid competency building. Because today, we want product design engineers. Normally, product design engineers, to develop them in an organizational environment, it takes about 4 years. Very difficult. Why? Because you go through departments, you go through functions, it takes years. Instead, in a snapshot I gave you, these are all the various stages or phases as a part of the product life cycle. So when we go through the product cycle in a very quick way, your learning improves quickly. So that is one reason. And new product introduction. Because reverse engineering, if you copy, we call it as low or level 1. It's not a good thing to do, it's illegal. You copy a product and market it, it is illegal. For the purpose of understanding knowledge, you can do it. Okay, but do anything below the radar. Knowledge building, we can do publicly, no problem, because we are trying to make our engineers trained in a particular product. And value engineering, we want to reduce the cost, because we worked some 10 years back, around 2001, for one customer, very leading automotive customer. He said, I want to launch a product in the market. Okay, what should be the price of the product? Then he said, my competitor is selling at this rate. So we want to reverse engineer the entire car, 10,000 parts, identify each component. Now you compare with my product structure, item by item. Okay, where is my cost coming? So based on that we can price it. Can you see? That's what we did. Finally they fixed the price. Of course that's your product still going strong in the market today. So value engineering basically is to reduce the cost of any of these things. That's why when you buy a car, don't buy any new car in the first 1 year. It will have a lot of problems. And don't buy a car after 18 months of introduction. Why? Because they have started doing a lot of value engineering. Yeah? You buy a car between 12 and 18 months, you get a product which is really good with less failures, but also it would not have been value engineered. Many things would have been taken away which you will not notice. Fine, next slide. Okay, so we are using specifically for learning, knowledge building. Okay, so there is a what you call teaching methodology called the code-based model of learning. The code-based model of learning, what they are telling is, if you touch and feel a part, learning happens. Instead, if I give a lecture, if I allow you to do a reverse engineering, I think we would have learned a lot. So we are following a system of called we give realistic experience in reverse engineering. So when you interact with the parts, you identify the material, you measure the volume. That means essentially learning happens. Okay, reverse engineering and re-engineering. So reverse engineering, I said, there are 3 levels. Level 1, you have a product, you make the specifications. That's level 1. And you use the specification as such, it's illegal. Especially for commercial purpose. Fine. That's level 1. Level 2, now you go to the function, you go to the geometry, look at the material, you make changes. Because you know the function, I said, 4-legged chair, 3-legged chair, 5-legged chair. It's possible, you can change the concept. You can change the geometry, material. That's a level more. In this level, when you are changing this, your margin, we say margin, what is margin? Factor of safety. Okay, you look at this situation, you got a 3-leg chair. The load is distributed on three this thing. So you got some stress for this material, this is the maximum stress which is acceptable, strength stress comparison. Now, it's going to have certain, what do you call it, margin or factor of safety. But I have 4 legs, maybe geometry is different or same, let's say, let us assume same. That means it has a higher margin. I got 5 legs, same geometry, I got a higher margin. But whereas in value engineering, we look at the functional requirement and set the margin or factor of safety. This is interesting. Why? Because what is the load likely to come on a chair? For that load only we need to design a product. We cannot design some load which is not in real life, in the product's life cycle is not going to come. So in re-engineering what we do is, with reverse engineering as the input, we change the parameters. We change the parameters. This is level 2. Level 3 is, look at the concept. Okay? He is achieving this function with this concept, with this physics. Can we achieve the same function with a different concept? Okay? To give you some idea, you look at actually, I want to raise the temperature of a body. Look at the different physics at play. You have your microwave oven. The microwave oven comes with the geometry and material. The function is increase the temperature of your body, increase body temperature. Now, you also got your induction stove. It comes with the entirely different physics. You also got your gas stove. You also got your kerosene stove. You also got your wooden stove. But basically, the function is same, increase the body temperature. But it comes with a different geometry, different physics. Different geometry, different materials, obviously it's going to be different physics. So one function, one geometry, one material, it's one physics. Okay, so when you discuss at level 3, that means you are looking at the concept level. Okay, is this the nice concept? 20 years back, I don't know how many people used microwave oven or induction stove. Today, it is going in masses. Why? Simple. Today we have the technology by which you can manufacture these components at the appropriate cost. So that is the difference between reverse engineering and re-engineering. Next one. Okay, level, system-wide, subsystem, dissection, and individual component. You can do at a system level, an assembly, sub-assembly, or a part level. Next one. And the system-wide, you start with the customer requirement, engineering requirement, functional specification, prediction of subsystem and components. This is what we do, system level. Next slide. Subsystem level, you have to document the disassembly, define subsystem, subsystem functional spec, determine physical and mathematical principles. Okay, look at your, in bike you have a brake, disc brake. Yeah? So like, it's a very simple, physics involved. You are using only 2 principles. One is a friction, other one is a lever. That's all. But when we say brake, all brakes should have minimum these 2, except hydraulic brakes. Maybe you get the lever, actuation in a different way. But the physics is same. You have friction and lever. Put together, you have a brake. If you look at the bike, the disc brake bike, yeah, you look at, actually there is a clamp. This is going to hold the disc. Okay? The friction is the concept by which the vehicle is coming to a stop. So this involves calculation. What calculation? Friction. You can calculate coefficient of friction, normal forces. The point is, that is where your mathematical principles are coming. But please understand, a complicated equation you will not encounter when you do the concept design. Very simple equation. I say all the time, okay, to my engineers, if you understand your simple machines, it's easy to understand the complex machines. Because we don't understand the simple machines, we cannot understand the complex machines. There are only 6 simple machines. You understand your simple machines over. Every product, your function can be defined in terms of your simple machine. Only thing you look at little patiently. Okay, individual component level, we get the material, geometry, and the manufacturing process. Next slide. Okay, difficulties actually. What is the difficulties? Okay, many a time the solution, we have a solution domain, and between the construct and abstract. I said actually, when you do reverse engineering, you should go go into the mind of the designer to understand what exactly was running his mind when he designed this component. Little difficult, but then if you patiently run through, you can definitely learn that. And there is also hierarchical. Many times people get confused. Okay, at what hierarchy this component is coming? That's where your product structure helps. Next slide. Okay, this is a product. Please, next slide. Okay, next. No, next. Okay, this is deliverable. This we call it as technical data package. When you perform a reverse engineering, what is it that my customer is going to get? Okay, I got form. Form is nothing but shape plus material. Shape plus material. Fit. Now, what kind of a fit? Yeah, this is an interference fit. Okay, what kind of a relationship I got? So there are only the two major relationships. One is a mate, other one is that what we call fit. And then function. Function we discussed elaborately. Tolerance. Tolerance is coming because of variation in the manufacturing process. Okay, so tolerance is accepted. And surfaces, manufacturing methods, material, size, cost, product specification. So the detailed technical data package, different customers want at different level. Next. 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 So there are, 1 minute, go back. There are about 46 items that you can accomplish with a typical technical data package. A complete system, you need all these 46. Otherwise it's not complete. Yeah. So the project scope can be a question of it, some of this, okay, in different combination you get check over it. Next one. Okay, this already we ran down. This is the process. So that is very this thing. So I already mapped it here. Next one. Okay, the benefits, this we discussed. Major benefit is that basically reverse engineering started with military systems. In the military system development, you got a development supplier and a production supplier. Normally the development supplier will not share any of the technical information, so a technical data package needs to be developed with a tested a tank or any of the different systems. So when you have the test or build and then use the build for reverse engineering, so that's the reverse engineering started. But today reverse engineering is done in every organization. It's competitive. The reason is everybody wants to know what is the other competitor is doing. So you look at the cell phone industry, every 3 months you see Nokia introducing at least some 20 or 30 models. It's very simple. Because very early on, at least around 2003-04, something like that, we worked one industry packaging for Kevin Car. So many of the packaging for Kevin Car are designed by us. The biggest challenge in that industry, fast moving consumer goods, is that the packaging design has to be completed in 1 week's time. Yeah, and your tool development has to happen in about 2 weeks' time. Essentially, in about 1 month's time, yeah, I am changing my design. The package itself will be changed. So what happened is, it's a very highly, a stress-intensive activity. Why? Because every week we are releasing 20 or 30 designs. And for tool manufacturing, it goes to about, say, finally the management will approve some 5 or 6 designs. And for all these 5 or 6 designs, you have to develop the tool, and the samples need to be ready. It has to go to the management, approve the samples, and then finally it is produced to put on its supermarket shop floor. Supermarket rack. When I put the rack, that's also the same thing I also do. Okay. So my competitor is coming. He buys a couple of shampoo bottle. He goes, takes back, does the reverse engineering. He precisely comes with something very similar. He makes some shape changes. He comes with a new package. That same thing I also do. Why? I am looking at my competitor is looking at me like this. So the trouble is, this is a game. Okay? After say about 2 or 3 years, we are fed up. Why? Because every time we release a product or our competitor release a product, when I release the product, my competitor is there in the supermarket. When I am releasing, so obviously that's a race. We finally found out very difficult to manage because people are becoming burnout. People work for 22 hours. Okay, so they release one design because they start a design and complete a design, they will not go out of office. Yeah, that is very, very difficult. At some point in time, we said, it's wrong. But you get a lot of money. Why? Because this is so much stress. Okay, some point in time we have to throw off. So the industry uses this for acquiring competitive knowledge. What my competitor is doing, for that they are using. It's legal, illegal, the debate is going on. But as per US law, reverse engineering is perfectly legal. Perfectly legal. But there are certain do's and don'ts. Fine, that's something is like very this thing. It depends. Like you can do reverse engineering, but you are not supposed to do anything at level 1. That's not acceptable. For knowledge building, you can use it. Anything you can do for level 2, level 3, you can use it, no problem. But you cannot do level 1 to level 1. No, that's not acceptable. Fine. So you have questions? You are supposed to ask me, you are not supposed to discuss among yourselves. Okay, so my physics professor in my undergraduate class used to tell, okay, at the end of the class he always asks this question. You have any questions? Like you all kept quiet. Then he will make a statement, okay, either you understood everything or you didn't understand anything. Okay, the first is not a possibility. Okay, you don't ask a question, that means you didn't understand anything. Am I right? Hey, get up! Say yes or no. So, no, sir, you didn't understand anything. Am I right? No, sir. Huh? No. No, say yes or no. Okay, thank you for your time.